All right, everybody, it's time for day 2 of our Stats Medic on Chapter 5. This is probability and the general addition rule. This is where we get to get some really powerful math tools to deal with theoretical probability. And we'll start this now. So, what's the probability of being a brown-eyed female? So to answer today's question, we're going to randomly select 10 students to come up front. Of course, we're going to do that kind of virtually. We're going to use these students to answer the following questions. So in any given class, there are males and females who have blue, brown, or green eyes. And we're going to create a table that shows all possible combinations of these eye colors and gender. So we've got that table right over here. Male and blue is male and blue, male and brown, male and brown, male and green is male and green, etc., etc., etc. You know how this goes, hopefully. So we'll get in the basic probability stuff here once we have this. This is really a two-way table. And we call it a two-way table because we are presenting two different variables, in this case gender and eye color. So in our two-way table, we have our 10 volunteers. And let's see, using the 10 students chosen, let's find each of the probabilities. So the first one is male. So what we're going to do is we're going to say out of the 12, there were 12 male students out of a total, let's pick a good one, out of a total of 10. Why did I get to 12? Hold on, I'm adding wrong. Well, I guess for today, we'll just have to do 20 for this one. That's not a big deal. So out of the 12 students, out of the 20 students, 12 of them are male. So we're going to make a fraction using these two. So 12 divided by 20, or 12 on 20 is 0.60. And we could do the same thing for the females in our group. That's going to give us 8 out of 20, or 0.4. Notice that 0.6 plus 0.4 add up to 100%, and that's a good thing. The next one to look at is blue eyes. Now for blue eyes, we're going to take a look at the column total and divide it by the grand total. So 3 divided by 20 is 0.15, or 15%. And then the rest of these are pretty much the same thing. 16 brown-eyed people divided by 20 is 0.8. And then 1 green-eyed person is 1 out of 20 total people in our sample. And 1 out of 20 is 0.05. Now things get to be kind of interesting because we're going to be taking a look at male or female. Now before we learned that, these right here should, if these are mutually exclusive, then we could just add their probabilities. So the probability of male or female, that's going to be the probability of male plus the probability of female, and that's going to be 0.60 plus 0.40. Unsurprisingly, that's equal to 100% because everybody in the sample was either male or female. The next one is blue and brown eyes. So let's see, probability of blue and brown, because they are mutually exclusive, that's going to be equal to the probability of blue plus the probability of brown. That's 0.15 plus 0.8, and that's 0.95. Okay, so that takes care of mutually exclusive. So you probably are thinking, what comes next? Okay, what about male and blue eyes? Now this is what we call not mutually exclusive. I can show you why. We can see that there are two people that are both male and blue eyes. So right over here, we would write the probability of male and blue is 2 out of 20. 2 out of all of the 20 students in our sample, our virtual sample, had blue eyes and were male. 2 out of 20. So that is not equal to 0, and that's why not mutually exclusive. So how do we figure out this one? Okay, so to figure out this one, what we're going to do is, let's copy this table over. If I was to do all of the males, that would be 2 plus 9 plus 1. And if I was to add all the people who had blue eyes, that'd be 2, this 2 right here, plus this 1 right here. So hopefully you've noticed that that corner one right over there, the 2, got counted twice. So if I want to use simple and subtraction and addition here for not mutually exclusive, I'd start off by adding the probability of male and the probability of blue. But then I have to subtract the probability of male and blue because it was counted in both the male set and the blue set. Which would mean I'm going to add 12 out of 20 for the boys, males, plus 3 out of 20 for the blue-eyed people, and then minus 2 out of 20 for the blue-eyed males that were counted twice. So when you add that together, you get 13 out of 20. So this idea of double counting the AND is very interesting. Now, the other thing that you could do here, actually, let's get to the other thing once we look at our other not mutually exclusive. So can we do the same principle for female and brown-eyed? Now, I should be saying female or brown-eyed. So let's count how many females we have. Let's try to do this with nicer colors. Let's do females, that's 8. And then brown eyes, that is 16. And then both here, that would be 7. So the probability of female or brown eyes is a probability of female plus a probability of brown minus a probability of female and brown eyes. So that's going to be 8 out of 20 because there were 8 females, plus 16 out of 20 because there are 16 brown-eyed people, minus 7 out of 20 because there were 7 females who were brown-eyed, and they're counted in both the females and in the brown-eyed counts. So that's just equal to 17 out of 20. Now, I was going to say there was alternative to this, and an alternative that you can do is just count all of the boxes, basically, that are both brown and female. So what I mean by that, well, we've got 1 blue-eyed female, plus 7 brown-eyed females, plus 0 green-eyed females. We don't actually have to put that there if we don't want to. Plus 9 brown-eyed females, or 9 brown-eyed males. Because everybody who I've added together were either had brown eyes or they were female. So if we add up all of those, and notice how it makes this nice cross over here, that's going to equal to the same thing, 17 out of 20. Okay, so let's move on. Hopefully that makes sense to you. And we're going to find the probabilities and explain why the answer makes sense. How about not green eyes? So for number 5, we're going to find each of the following probabilities. And that first one is not green eyes, and the second one is not male. So this is a little bit about what we were talking about with the previous example. This is the complement rule. So what we're going to do is we're going to count how many people were green-eyed. And then we're going to subtract that from 1. So for the probability of not green-eyed, we're going to do 1 minus the probability of green eyes, which is 1 out of 20. So 1 minus 1 out of 20 is just 19 out of 20. And it's that easy. How about the probability of not male? Well, that's equal to 1 minus the probability of male. And that's 1 minus 12 out of 20, which is 8 out of 20. Naturally, if we already knew that we're just talking about the females in the class, then we could have just said females are 8 out of 20. So there's many times more than one way to deal with these probabilities. And with that, we can go into our big ideas here. So first thing that we talked about were the two-way tables and Venn diagrams. Now, we didn't do any Venn diagrams, but you should be familiar with the way that Venn diagrams go. Venn diagrams, they kind of look like the MasterCard logo, I suppose. And the central part here, when we do this in math, the central part is where we always want to start. That's the probability of A and B, both things happening at the same time. This one over here would be the probability of A happening, but B not being true. This one over here is a probability that B is true and A is not true. And on the outside of the circles is also important to the Venn diagram. That's equal to the probability that A and B are both not true. Now, what you will notice, what I've done is I've correlated those areas in the circles with parts from the two-way table. So if we have two different events, A and B, the probability, let me get a pointer here. Two different events, A and B, there's B and here's A. The probability of A and B is always going to be this one right here. This is the probability of A and B. And that corresponds with, what did I do here? Let's try that again. The probability of A and B right here, that corresponds with the center section here. Okay. Now the second one would be, what about the probability of A is true, but B is false? That's this right here, A and B complement, and that's going to be this part of the circle right here, the one that looks like a crescent on the left side. Okay. Now the third one would be the probability that B is true, but A is false, and that's the crescent on the right. A is false, B is true. And of course that last one, that's going to be the probability that both A and B are false. This number right here, that corresponds with this number over here, and that's actually all of this blank space that's outside of the circles. So I know some people think better with the Venn diagram, so I don't want to say too much ill about it, but I actually don't find them super helpful myself, but that has nothing to do with you. So we talked about the general addition rule. If you have two things that they don't have to be mutually exclusive anymore, and if they're not mutually exclusive, then you subtract what they have in common from the sum of the two probabilities. That was this one right here, number 4. Next, if they are mutually exclusive, then of course this rule counts because the probability of A and B is equal to 0. So let's see if we can put these rules into use with our check your understanding. So what is the relationship between educational achievement and ownership? Home ownership, that is. A random sample of 500 U.S. adults was selected. Each member of the sample was identified as a high school graduate or not, and a homeowner or not. So the two-way table displays the data, and suppose that we choose a person at random. We'll define G to be a person is a high school graduate and H to be a homeowner. So in plain language, what does GC mean? So GC, the complement of G is a high school graduate, so either you are a high school graduate or you're not a high school graduate. So PGC is a probability that a person is not a high school graduate. Now in order to figure that out, we're going to have to figure out the marginal totals of this table. So we're going to need the marginal totals here, and I've just replaced a table with another table with the same information that has marginal totals. So the probability that a person is not a high school graduate, that's going to be 190 out of 500. That's equal to 38%. Next, explain why the probability of G or H is not equal to the probability of G plus the probability of H. Well, let's see. The probability of G includes, those are the people that are high school graduate. That includes all of these people. The probability of H is the people who are a homeowner, and that includes all of these people. So that means that 221 there got counted twice. And since the probability of G and H is not equal to 0, that means that G and H are not mutually exclusive, which means we have to use the general additive rule, general addition rule. Okay. We can't use the addition rule for mutually exclusive. We have to use the addition rule for not mutually exclusive events. So they're not mutually exclusive. So the probability of G or H is the probability of G plus the probability of H minus the probability of G and H. The probability of G is 310 out of 500. The probability of H is 340 out of 500. So 310 plus 340 minus 221 out of 500. And that's equal to 429 out of 500. Lastly, we'll make a Venn diagram. Okay, not lastly, apparently this is almost lastly. We're going to make a Venn diagram to display the samples, sample space of this chance process. We'll start off with our square. Actually, let's just copy and paste a template from online. And let's label the circles. Let's make the one on the left homeowner, and then we'll make the one on the right not homeowners. Sorry, I meant high school grad. So it's kind of important that when we do this that we have one of the, let's say the row titles has one circle, and then the column titles as the other circle. I made that mistake just now, so you don't have to. So inside this, the I-shaped, the almond shape, that's going to be both homeowners and high school graduates. And that's going to be 221 people. So 221 people are both homeowners and high school graduates. Now we'll get these other numbers. Inside the moon shape, the crescent moon on the left, that means homeowners but not high school graduates. So homeowners but not high school graduates up here, that's this 119. They are homeowners, but they're not high school graduates. So over here, we're going to put a 119. Now on the other side of that, on this half moon on the right, they are high school graduates, but they're not homeowners. So they are high school graduates, but not homeowners. That's going to be 89. Now outside the circles, they are neither homeowners nor high school graduates, and that is 71. So notice that the numbers that appear in the diagram are not marginal totals. Anything that is a total does not end up in a Venn diagram. Last thing here, I think, yeah, now we're last. Write the event is not a high school graduate, but is a homeowner in symbolic form. So let's get the numbers out here. What is not a high school graduate? That's going to be G complement. And is a homeowner, that's going to be H. So is not a high school graduate, but is a homeowner. Now don't worry about the but part. Both of those things have to be true. That's going to be the probability of H and G complement. So where would that be on the table? On the table, high school, not a high school graduate is this column. Is a homeowner is 119. So that's going to be 119 out of 500, or 0.238. So that is our look at the two-way tables and our corresponding Venn diagrams. The mutually exclusive and the general addition rule, those things really do give some students a little bit of a headache. So when in doubt, if you're not sure if two things are mutually exclusive, always use the general addition rule. And then if it turns out that they are mutually exclusive, then you don't really make an error. It'll still work out the same way. So hopefully that piece of advice will help you, and I will see you guys next time here for more stats. Peace.